finishing chamber has components within it. It has the sand, gravels, charcoal, and the rocks. These components are separated by a foam, so they will not mix up. So within the components, the sand is the first layer. So the sand is there to remove larger particles which are bigger than it from it. After that, it moves to the gravels. The gravels also perform the same function. It also removes debris. It's a type of particles from the water as it passes through the sand to it. And from there, it moves straight away to the charcoal. The charcoal is there to remove toxins. It has a porous surface which has tiny pores within it. It acts like a spongy material which removes toxins effectively from the water and then moves back to the gravels. The gravel also perform the same function as removing debris. We assume some particles may pass through the charcoal and get into the next layer. So the gravel is there to remove those particles from there. Electric current is being supplied to the electrode, which is the anode and the cathode. The anode is the positive terminal and the cathode is the negative terminal. The anode releases metal ion into the water, and the cathode hydrolyzes water surrounding it into hydrogen gas and hydroxide groups. Electrons move freely from the cathode to the anode, which destabilize surface charge on suspended solids and emulsified oil. Metal ion complex with hydroxide ion to form flocs with the contaminants, which is then lifted up by the hydrogen gas from the cathode.
Water from the electrocoagulation process moves to the continuous stirring tank reactor. The continuous stirring tank reactor stirs the water, which makes the floc stick together and settle down by gravity.
Which was designed and built by Mr. We'll be running a test on a sample of water which we classified as size 4. So this sample of water, the transmitted measurement values of turbidity to be 0 JT, which stands for 0 Jackson turbidity unit, which means that there is no haziness or cloudy appearance of the water, which makes it look safe to drink. But in this case, the water might look safe to drink, but it has a pH of 6, which makes it acidic, and it has a dissolved oxygen content of 0 to 4 ppm, which means that it has little or less amount of dissolved oxygen in it, which makes it unsafe to consume into the human system. For this system to work, it needs a source of power. And the two main sources of power which this system will be able to run on is solar energy and electrical energy. But in this case, solar energy is not important or it's not required, so we'll be using the electrical method. First, we need to connect this plug into a power outlet and turn it on. And make sure that the system is on by turning this switch on. And to know if the system is on or off, we can be sure by checking if this light is on or off. When this light is on, it means that the system is working and is ready to run tests. If it's off, it means there might be electrical problems which might need attendance to. Water must be poured into the inlet or Pfrs for the whole thing to start. This system is divided into several filtration phases, such as the traditional filtration system, the EC, 2 CSTRs, 2 Pfrs, and PT and cooling chambers. But first of all, since water will be passing through this traditional layer, we will be going deep to explain how this part or system of the project works. So, please follow it.
Turn on the switch.
So in this traditional filtration system, we have several layers which are being separated by filter paper. The first layer inside is sand, which removes suspended particles from the water. The second layer is gravels, which remove precipitates, which might have escaped the first layer. As you go deeper, the water will then move into the activated biochar, which uses the process of bioaccumulation to trap odor causing and color causing particles onto its porous surfaces. The last layer is limestone, which corrects the pH of the water. Through the inlet, it will take about 10 to 12 minutes for the water to pass all the layers, which are arranged vertically, to move into the next section of the filtration phase, which means that we have to wait for 12 minutes before the water moves from the traditional filtration system to the next stage, which is the electrocoagulation.
So the electrocoagulation process is a system that purifies water as a result of supplying electric current to the water. So we have the anode and the cathode. We use aluminium as the cathode and iron as the anode. So in this case, you can see the water content inside. So the function of the anode is to supply metal ion into the water, and the function of the cathode is to supply electrons from cathode to the anode, which will destabilize surface charges on that suspended solids, emulsified oils, heavy metals, and many more. And blocks will be formed by hydroxide ions, which will form heavy or block compact particles, which will then be lifted up by the hydrogen, which will be produced on the cathode. After the particles in the water has been destabilized by the electrocoagulation process, it moves to the first continuous stirring tank reactor. This tank stirs the water continuously for flux formation. So you see that the flux will form in the first CSTR, and it will automatically open for the flux to get into this can. After the first CSTR, it moves to the second CSTR. The second CSTR
chlorine is injected into the second CSTR for disinfection of materials such as E. coli, Shigella. After the water has been disinfected, it moves to the first PFR, that's the Plug-Flow Reactor. The Plug-Flow Reactor mixes the water.
So in this advanced wastewater treatment plant, you have two PFRs, which means Plug-Flow Reactor. The Plug-Flow Reactor has similar attributes as of the CSTR, which reduces the kinetic energy of the water and hence turns the dissolved particles into flux, therefore making it much more denser. So as you can see, we have two Plug-Flow reactors here. One is here and one is here, which are aligned, which increases the kinetic energy of the water coming into the CSTR. As you can see, you have automatic valve systems which opens and closes for the water to pass through, which moves then into the activated biochar.
PFR, the Plug-Flow Reactor. It moves to the adsorption chamber. This is where things really get interesting. The adsorption chamber comprises of an activated charcoal. The activated charcoal is a carbon that has been treated with oxygen. This treatment results in highly porous surface. This surface absorbs toxins, so the chlorine injected in the water is not good for consumption. So the charcoal in the water, the activated charcoal, will absorb all the chlorine that is injected into the water from it. After the absorption chamber, the water moves to the heating chamber. The heating chamber heats the water to reduce the concentration of chlorine in the water. And lastly, the water moves to the cooling process. This is the cooling chamber, and this is the heating chamber. Here too is the absorption chamber.